Good morning. How's everyone doing today? The little SLI that could, that's the name of this talk by Sophia, that's me. I'm not sure if you're familiar with the story of the little engine that could, so I'll give you the TLDR, as they say. This story is about a train that brings candies and treats to all the little children who live just across the mountain. One day, the train is chugging along, but then its engine suddenly wears out. The toys and train ask for help. A snazzy new train passes by and says, "Sorry, bro, I'm built from shiny new best practices. I can't help you." So it goes smoothly up the mountain on its own and disappears. Then a big freight engine shows up. Gruffly says it's too important. It has one job, it does well already, so it won't help. And it goes over the mountain and disappears. Then the toys see this little blue engine coming near. In the story, it's a she. The train and toys are hopeful that she'll help. She's small. She isn't sure that she can do much, but says she'll try. And she tries, and surprise, surprise, she does it. The little engine delivers the children all their treats and toys, and they were happy. That stop motion was really fun to make, and it took a very long time. But the goal of today's talk is to talk about what implementing SLOs look like for us at Betterment. I work at Betterment. I didn't mention that. I should mention that. We're also hiring. More specifically, it's about how we gathered our SLIs. But before we get there, let me introduce the context in which this conversation about SLIs even came about. A few givens, if you will. Writing good code can be hard, right? By good code, I mean well-documented, well-instrumented, well-tested code. It's hard. SLOs, they're also hard. That's not particularly profound, but this is one of the driving points of a lot of the work my team and I have been doing the past couple of years. Choosing the right SLI is a complicated matter. I'm here to talk about how we chose some SLIs and how choosing perhaps the most generic ones worked well for us. This is a story about how my team tried to make choosing SLIs and crafting SLOs as easy and frictionless as possible, and how this approach was influenced directly by how we built out our CI and CD pipelines and the rest of our platform. I was really intimidated by SLOs for years. I felt like it was this big, daunting thing that only geniuses at Google could implement. But then I realized that SLIs and SLOs are just tools. And tools are not merely valuable things to fuss over. They are meant to help people wield changes in the real world. Everything we're trying to do here is intended to help humans deliver goods where they need to go. So by reframing the problem to how can we help engineers, humans, collect the right information so that they can best do what they need to do in the world, I was able to make some progress. And so I hope that our approach might inspire some other folks who've been just intimidated into believing they could never make progress. You can do it. A couple years ago, it started to become apparent that the engineers at our org wanted to start prioritizing performance, to start focusing on data-driven development instead of building from Figma designs and calling a feature done by how well it matched the original UX. They wanted to design their features with proper instrumentation. Different teams tried different things to solve these problems, which led to solutions that were almost impossible to replicate across business lines or teams. And yes, when I search back in time since 2016, the majority of messages about SLOs and SLIs originated from me, but that's neither here nor there. So we took our learnings from how we designed the rest of our platform, where we prioritized standardization over infinite feature sets, ensured principles drove the design. Opinionated frameworks come with pros and cons, but by eliminating certain choices, they actually contribute to faster development and better engineering efforts. Engineers can focus on doing what they need to do. John Ousterhout, I think, talks about this in his philosophy of software design. Focus on eliminating complexity as a means to good, solid design. And last but not least, ensure a faster development feedback loop. Constantly iterate to breakthrough, which is a central tenet of Betterment's philosophy. So the state we were in was lots of teams tried lots of things in the past, which meant observability solutions were varied. Having so many different ways of instrumenting code, creating monitors and dashboards, according to how team vibed, resulted in dead alerting systems when folks would leave the company. One-off monitors that couldn't be easily replicated for new apps or systems, because the discoverability was limited due to how Datadog presents its resources. This approach reinforces tribal knowledge, which isn't how you scale. I've mentioned this already, but for our observability needs, we use Datadog. I love Datadog. The main problem here has been that there's just so many knobs and gadgets to play with. It takes quite a while to understand how to interact with it. My team might be Datadog pros at this point. We're SREs. It's kind of, we're pros at everything, kind of, but in a minimal way. But a new engineer might have zero idea of how to find an alert, let alone create one. We needed the right abstraction to hide the complexity of Datadog. Prioritizing standardization has driven my team's philosophy for some time. Keeping the interface to different systems, CI, CD, data pipelines, logging, dashboarding, package management, the same across the board, and keeping the output the same across the board, but obviously allowing flexibility when needed. It's allowed our really lean SRE team to build a lot of really powerful tooling for over 100 other engineers. Given that everyone's interactions with Datadog was so unstandardized and so widely varied, it became clear to me that this project of the SLI and SLO tooling was not just about a standard interface, but also about reducing the complexity of the developer experience of observability tools. So I took what we learned with our other systems, and I thought engineers just need a standardized way to instrument their code, a standardized way to alert on their code, and a standardized way to keep tabs on their code over time without stressing themselves out all the time. So yeah, they need SLIs, they need SLOs, but they also need a simple way to create, manage, and discover them. My first approach was useful, but perhaps not the best. My goal of this talk was to share the journey, so that includes where we stumbled. I jumped straight to custom metrics because these always seemed, from a code hygiene point of view, to be the strongest way to represent an accurate picture of the user experience of a specific domain. So I thought, let's wrap some micrometer and statsd classes with a bit of syntactic sugar to make it easier to emit custom metrics in a standardized fashion, to make the tagging consistent for those power users to do what they need to do with the information. And I'm not sure about you, but this had as much success in legacy code bases as asking a new mother to sleep when the baby sleeps. Super important, right? But somehow really difficult to do. Asking folks to go into legacy domains and instrument consequential methods aligned to critical user experiences with custom metrics wasn't going on anyone's roadmap easily. New Rails engines, new Java libraries, forget about it. Clean slates means you can use all that new hotness with ease. Any new projects were properly instrumented and statsd and all of that. But what about that rusty old engine or that big freight train with one job? And what about our sluggish little engine that's still stuck, waiting for help? Teaching people who were contributing to legacy code bases how to use the right statsd methods, how to use active support notifications, how to add micrometers to their classes, when they could instead just be writing their normal, well-documented and well-tested code, it didn't have the rate of success I imagined. And so I learned that to get teams on board with this new observability-driven development approach, we'd have to facilitate easier instrumentation. And I know what you're thinking, statsd isn't hard. It's not that the concepts were difficult, it's that legacy code bases are difficult to instrument after the fact. And I know a lot of companies are like that. A lot of startups that are, have to get product market fit quickly, and then they become successful. They don't have the best history of observability. And that's why we're all here this week. We're trying to change that. So we went back to the drawing board. Power users were happy, but few and far in between. It was a new engineer with a very busy engineer who just wanted to keep tabs on error rates and latency for their code. And it was those people that we needed to help. They didn't want to spend days or weeks out of a product cycle focusing on performance and telemetry and solving those problems. We needed to find a way to slide in SLI collection with the same ease that RSpec, for example, provides a testing framework. Without a framework, an engineer would have to go into Datadog, figure out the right query, or find the right suggested monitor creation button on their APM page, and create that. And then if they ever left the company, well, that might go silently off into the ether of some abandoned Slack channel. And ultimately, the complexity of Datadog was deterring folks from doing much with it. And we had the same problem with Splunk and New Relic before that, so I'm not trying to harsh anyone's mellow. Before we could solve anything with more tooling, we need to really define the problem space. Observability as the problem isn't super well defined. We knew we'd need a way to reduce the complexity of engineering's interactions with our observability system. People wanted to prioritize performance, but it was such a drag that all the teams couldn't do it in a sustainable and consistent way. And so we also knew we would need to ensure consistency in those interactions through a standard interface of some kind, like I've mentioned. We also definitely wanted to eliminate the abandoned dashboard, abandoned monitor problem. To make sure we weren't solving a problem no one asked us to, we'd have to validate it first, which didn't take long. The question of which team owned an app or an alert was an oft-raised one. So we were able to simplify the problem space to code ownership and code accountability. And I was thinking mainly about how to provide a solution to this in a frictionless way. Another engineer and I chatted and thought about how we could do this in the simplest way possible, which really meant go to the code. We mused on the idea of creating some kind of code-level keywords that we could introspect the code base for during CI or at deploy time and then just do something with. This would be something we could lint on, and thus ultimately require. We thought, how can we make it easier for engineers to automatically know they own something, and also that the thing they own needs to function in a certain way? We were already doing this with background jobs through a simple Ruby method called job owner, the value of which we used to find a Slack channel for notifications. We'd inspect a YAML file, send alerts to whichever Slack channel matches the job owner. It was pretty lo-fi. It seemed like we could mimic this, but I knew that we probably need some more configurable options than a Ruby method, which just didn't seem structured enough. Someone might easily forget to add it since it's just an extra method. I knew I'd want to have a corollary solution for Java folks, so we decided to go with the keyword annotation combo. Here's the Rails one. It would have to make sense in the Railsy context, so of course it corresponded to different actions and mirrored Rails class inheritance. We provided reasonable defaults for everything, so you could theoretically just add owner, SRE, and our code handled the rest. The Java one matched in functionality, but led with the concept that it was explicitly for monitoring, since there weren't as many Java subteams as there were Rails teams working in a single code base, so ownership wasn't as much of a problem. They also had their own internal way of defining reasonable defaults, which of course resulted in like 4 other really very big verbose classes that I won't bother putting here because #Java. So back to the implementation. The interface needed to be simple, but the internals, well, that can be as complicated as it needs to be. And this is a complicated diagram. This is a workflow of how we use those code annotations to create SLIs. At deploy time, we'd have a rake task or a Gradle task. Eagerly load all the classes in the code base, find all those instances of owner or Datadog monitor, coerce all those options into JSON blobs and then print them to a file. Our CD CLI would then load the file, validate it, send it to a web app API that would then create database records for the JSON blobs, blah, blah, blah. And then monitors would be created in Datadog. For every annotation, we would create monitors for latency, change in throughput, high error rate, and new errors for a latest deployment. And because it was version 1, and because you always make mistakes the first time, we would automatically Slack you if those monitors had violations. And I don't know about you, but latency monitors can go off frequently. So I thought, how can we let folks alert on their most prized possessions, their API endpoints, but also not destroy their sense of hope and accomplishment every day? We knew we wanted guaranteed coverage of code with monitors, so we just defaulted to false for slacking and paging and allowed those to be configurable for power users who really wanted to know. But we needed to do something with all those alerts that we now had. So the pièce de résistance, I knew SLOs were theoretically the solution to this, but this V1 of tooling happened in 2019. I'd been to talks about SLOs, read the Google SLO chapters, had this gut feeling they were the answer, but I didn't know how to do them. We focused on getting the SLIs created, properly tagged and standardized, and in the fall of 2020, Alex Hidalgo's book, Implementing Service Level Objectives, came out. I don't know if he's here. He must be here. He's giving a talk. I saw our next steps. I consumed that book faster than an Instagram feed. I was in love with it. It was so accessible. He outlined everything. And what I saw was a bunch of rules, not that they actually were, but I love rules. I love a framework any day. Rules and frameworks to me are the tools to help make change in the real world. I made a strategy doc like he recommended. It had a fancy table of contents at the top. I got buy-in from all the higher ups. I started writing more tooling to go along with our SLI collection. I was given the go-ahead to craft workshops and work with teams directly to think and implement service-level objectives for their services. I was on a mission. I was also at the end of my second trimester by the time I started these workshops, so there was a deadline. The folks that participated seemed to really enjoy the workshops, but it was hard to scale. It was difficult to get teams to dedicate a few days off their product roadmap to learn about SLIs and SLOs and actually implement them using the new tooling. So what's the answer to a human problem? Ours, at least, was to make the tooling even more self-service. So we'd already created an SLOs repo separate from the application code as part of the tooling. This was to enforce standardization, simplify the interface, prioritize discoverability, and decouple target SLO goals from application deployments. If you wanted to change your SLO from 98 to 99% coverage, for instance, you shouldn't have to rebuild and deploy app code. The SLOs were organized by repo, squad owner, and service, and it was all in YAML because SREs love YAML, with an accompanying markdown file that required folks to fill out descriptions of the chosen SLIs and the plan for revisiting and all of that. Datadog supports two kinds of SLOs, metric and monitor-based, so we supported two kinds of interfaces. Here's the metric one. You just plug in the right query. This was for our power users who are already implementing their code with custom metrics. Monitor SLOs were the most frequently one because they were the simplest to implement. You just plugged in the monitor IDs from your automatically created monitors from the owner or Datadog monitor annotations, and voila, there you go. So once you merged a PR of your new YAML file into the SLOs repo, that same CLI would ping our web app, and it would handle upserting the SLO in Datadog with your details. But there was another problem. You'd have to go into Datadog to fetch the ID of a monitor that was created automatically, which felt cumbersome. So that friction of plugging in monitor IDs led to V2 of the owner Datadog monitor annotation work, always iterating to breakthrough. We decided to support two new features, feature and tags. Tags were again for those 6 power users, but this time we added feature so that those that aren't power users could more reasonably associate DJ and controller monitors with SLOs. Of course, we can't forget our Java friends. So now you just put in the tags you added to your endpoints, and for this category and this feature tag, we create an SLO using all the latency monitors we've created for your controllers that match the feature add goal. And this is how it looks from a bird's eye view. Annotations map to monitors, SLO YAML maps to SLOs. And here's how we support discoverability. In addition to the SLOs repo, for those who might be on the product team and less entrenched in GitHub, there's a metrics section of our application platform. And yes, we built it, we didn't buy it. And we surface links to all your annotations in Datadog and all of the relevant information for your SLOs. The best part about this is that it worked. I came back from 6 months of maternity leave. I asked around about how the SLIs and SLOs worked for folks, and they did. For the folks who'd written their SLOs and turned off noisy alerts, they're actually able to allocate resources appropriately. Everyone knows SLOs work, right? But they can even work with what I'm calling a bit of lazy SLI collection. I was so focused after reading Alex's book, I don't know where he is, but can I call you Alex? The importance of getting absolutely the right SLI. It's critical to real SLOs that match our user experience, right? You can't futz that. But you actually kind of, sort of can, I found. What's next? Well, of course, we're going to keep improving our SLI collection. The best way to get as close to the user experience as possible is through client-side SLI collection. We have a plan for our React components to match our owner annotations elsewhere. What I've learned during this exercise is that it really does take quite a long time to transform the culture at an org with over 100 engineers, over 50 engineers. It's hard, and of course we're not done. Making it easy and simple to annotate your code and collect SLIs the way that we've done, it's really facilitated this journey. It's 1 or 2 steps away from automatic SLI collection, which I don't necessarily recommend, but it's a couple steps removed still from SLI-driven design. But we're getting there. So to summarize, engineers like to write code. They don't necessarily like to go back and instrument legacy code for performance reasons immediately, but yes, eventually, obviously, for very critical, important business things. Engineers need to instrument their code. Engineers need to write SLOs. Engineers like frameworks. They like routine, so we gave them a framework. We gave them a tool to wield to help them do real work in the real world. Thank you. That's all I got today. This is me on Twitter.